What I want to do in this video is further connect our understanding of the binomial theorem to combinatorics to Pascal's triangle. And so just to review the ideas again, if we're taking x plus y to the third power, and I'm just using this as an example that's a little bit easy to get our heads around, that's essentially taking three equivalent expressions and multiplying them by each other. You're taking x plus y times x plus y times x plus y. So let's call this the first x plus y, the second x plus y, and the third x plus y. And so if you're looking at the expansion of it and you're saying, well, how many ways can we construct xy squared? Or another way to think about it is, you have these three expressions. You're going to choose two of them to contribute a y and take the product. So for example, you could pick expression 1 and expression 2 to contribute the y. You could pick expression 1 and expression 3 to contribute the y. Or you could take expression 2 and expression 3 to contribute the y. And of course, the other expression is what's going to contribute the x. So you have three expressions. And you're going to choose two. To contribute the y. And so that's why you have this combinatorics idea. It's 3 choose 2. It's the exact same mathematical problem if you have three friends and you're choosing two to ride in a car with you and you don't care which seat they are going to sit in. You're just saying which two friends get to ride in my two-seater, or get to ride, what are the two friends that I am going to pick? Same way here. Out of the three friends, which are the two that I'm going to pick to contribute a y to this product? And then the third is going to contribute an x. Now let's go to Pascal's triangle and hopefully see that this is actually a very similar idea. So we could go to the same term, so the xy squared term, so that's right over there. And Pascal's triangle, I always visualize it as a map. So this is a node in the map, and I think about, well, what are the different ways that I can get to this node on the map? Well, I could have a y squared. I could have a y squared and then multiply by an x. And since we're multiplying an x, that's why I made this line orange. Or I could have an xy and I could multiply by a blue. So there's two immediate things above it that I can get to them, but there's two ways to get to this one. There's one way to get to this one. And so the combined ways to get to this one is 2 plus 1 is equal to 3. And just to make the connection between what we just said, what's really going on here is at each of these nodes, as we pick a path, we're essentially saying, are we picking an x or y from each of these expressions? So we number the expressions. Let's number them here. So let's say this is expression 1, this is expression 2, this is expression 3. So we said that there's three paths that could take us here. So let's mark them out. So there's this path, there's this path right over here that gets us there. And that's equivalent to picking the x from expression 1. Notice we pick the left-hand side. Then we go to the right-hand side. We pick the y from expression 2. And then we pick the y from expression 3. The last two, we picked the right path. We picked the blue path. So that's essentially one way that we could choose two y's out of these three expressions. Once again, one way to choose two y's out of three expressions. But we don't care about just that one way. We care about all of the different paths. So this was one way. Another way would be to go like this. So to pick a y from the first one, an x from the second one, and a y from the third one. Or pick a y from the first expression, a y from the second expression, and an x from the third expression. So it's really at kind of a fundamental mathematical level, it's solving the exact same problem. So hopefully this gives you a little intuition on why Pascal's triangle is connected to combinatorics and why they're both useful for finding binomial expansions.